Hello and welcome to Global Azure 2025. I am really excited to be talking to you about a topic that is near and dear to my heart, building scalable microservices with .NET Aspire, generative AI, and OpenTelemetry insights. I'm really excited to be part of the Global Azure Sevilla group, and my name is Harry Kimpel. I'm a principal developer relations engineer at New Relic. I have been a passionate software craftsman for many, many years. I started and have pretty much always been in the Microsoft developer ecosystem. Started basically many years ago as part of the Visual Basic 3 and Visual Basic 4 and have used various kinds of Microsoft developer tooling since then. I'm with New Relic since 2017 and have fun, enjoying the world of observability. And if I'm not in front of a computer, I like all things outdoors, hiking, biking, climbing. The skiing season just ended the last weekend. You can see this is a picture of the area I live in southern Germany, right at the border of Austria. I'm also the chief repair officer at home. And what does that really mean? Well, imagine, this icon here, this picture. This basically represents a spec for screws, for Torx screws to be specific, right? And you can imagine like all the angles and all the width and the details and the measurements. These are all really important for this spec. And if I, as a screw manufacturer, build all the screws based on this spec, I can rely on this spec to make sure that all of my customers that are buying the screws are basically happy with the definition and all the screw sizes and the different, specs around this. And then for me as a tool builder, if I build tools based on this spec, I can again rely on this spec to make sure that all the tools I build will always fit the specs for these specific screws. Of course, different sizes, but the spec is always the same. And then this makes me, as the chief repair officer at home, happy because I can use all the tools that I have and I can use all the screws and make sure that I can fix all the things that need fixing at home. So why is that important, especially in the world of software? Well, the rise of OpenTelemetry in the last couple of years has been really amazing. OpenTelemetry nowadays is a CNCF project. It was built from a merger from two different other projects, Open Tracing, focusing on the tracing aspects, and Open Census, focusing on the metrics. And they emerge into a single open standard for telemetry as part of your applications and services. And this is OpenTelemetry. The telemetry signals are metrics, traces, and logs. And they come with like a set of APIs, libraries, integrations, a collector service for telemetry that you can use to collect the data before you can hand it off to a full observability backend like New Relic. It standardizes the collection of this telemetry. Whatever I'm sharing today is based on OpenTelemetry with one aspect where I'm using some capabilities from New Relic, but I'll highlight this. The rest is really fully open source, open standard based on OpenTelemetry. The agenda for this session, I'll have a sample application implemented in .NET Aspire that we're using. We will then look at observing OpenTelemetry signals from this application in the .NET Aspire developer dashboard, which is amazing. And then also looking at how the same telemetry we can then visualize and gather some insights in New Relic as our observability platform. Lastly, there's also a section where I, of course, incorporate some generative AI into the application, and we'll want to make sure that how can we observe the aspects around generative AI into this entire picture. We will be starting with some New Relic capabilities, but again, there's also a lot of discussion, a lot of projects around how can we observe generative AI capabilities and telemetry using OpenTelemetry native capabilities. And this is what we also look into. We will use the sample application, but this is running in GitHub, in GitHub code spaces. I provided the QR code here that you can use to go through this in your own time. Again, here's the link, and I'll jump into this environment in a second, and then we'll go through the entire section here in GitHub code spaces. So you can see I headed over to my GitHub account and specifically the repo workshop.net Aspire GenAI OTel. As part of this, I provided a lot of instructions in the READMEs. The first is, a section around how to get started in GitHub code spaces. I already started my GitHub code space here, and you can see the current branch. This is the code space refactored goldfish, and this is where I have this entire GitHub repository already running in GitHub code spaces. So if you scroll down, again, there's instructions on how to get started. I'll skip all of this, and then I can jump into the first challenge for this talk. So in the description here, in the instructions, I'll ask you to, jump into the terminal. We then switch into the first directory here, the challenge1 directory, and then we'll get this application up and running. So of course, this is not a topic where I explain the basics of .NET Aspire, but you can see the sample application that I have available here in the challenge1. It has two different services, basically, an app.web and also an app.api service. These are two different services as part of my application. One is the front end and one is the backend API service. And then we also have this app host and the service defaults project. This is standard .NET Aspire terminology. The app host is basically the orchestration of all my services, and then the service defaults contains some default implementation that we use throughout this session. So let's go ahead and get started. I'll click the .NET Run project and we'll use the app host as a starting project. This should be up and running in a couple of seconds. And as I said, in the instructions, this should look like this, where we then have a link to our .NET Aspire developer dashboard available. So all the ports should be forwarded automatically for you. I can skip this here and go back into my terminal. And then you can see here, this is the refactored goldfish link to my .NET Aspire dashboard that I'm clicking on. This will bring me to the .NET Aspire dashboard. You can see I have the two different services here, the web frontend and the API service. I can explore some details around them, look at some environment variables, some definitions here, and you'll also find a link to the OTel exporter OTLP endpoint. This is a standard configuration to send OpenTelemetry signals, OpenTelemetry data to a endpoint. And in our case, this is sent to localhost 21.22.0. This is kind of like the collector that is used in this .NET Aspire developer dashboard. So I can then also jump into the UI for this application. Nothing fancy here. This is the standard .NET Aspire application, a sample application that I've implemented using the template. If you click .NET New and create a new application, this is what I used here. You can see this is the standard, weather service. This is actually interacting then with my backend service and gathering some weather forecast information. So if I go back into my .NET Aspire developer dashboard, I can then, of course, look at some information in the console. I'm looking at the logs. I can also look at the structured logs from the different services, like from my web frontend and the API service. And of course, I can then also look into the traces. And then here, you can then see all the different traces that were captured from the web frontend and the API service. And this one here is, for example, one that we captured that is actually interacting from my web front end all the way to my API service and the get weather forecast. So you can see this entire trace took 8.27 milliseconds, and how it breaks down into the different aspects of executing the GET request on the web front end, which will then forward the request to my API service to the GET weather forecast section here. This is nice. If I want to, I can click into any of these spans to get some further details around the specific aspect here. This is the API service, as I mentioned, and I can look at some parameters, some attributes that we captured automatically. Interestingly, also the logs are just a click away. So now this link brings me into the logs for the web frontend and the API service, and is already filtered down to the specific trace that we used here. On top of the traces and the logs, we can also look at some of the metrics that are being captured. For example, for the web front end, I can then look at the native metrics that we see here, like the HTTP server active requests, the request duration for the different requests, and break down into different median, P90 and P99 percentage or percentiles. I can look at the connection duration and so on and so forth. So a lot of different metrics that are captured by default. So everything that I just showed is also highlighted in the README for the first challenge. You can look at the screenshots of the application, the .NET Aspire, developer dashboard, the logging, the traces, and the metrics. So if you want to go through this again and look at some ways to get there, this is also mentioned in here. I also put in some high-level description, OpenTelemetry, what it is, some links to more further details and readings about traces, metrics, and logs. I'll explain briefly about OpenTelemetry in .NET Aspire. And basically, this extensions.cs file, as part of the app service defaults, will show you the details of how actually OpenTelemetry is configured. In the add service default section, there's a link to the configure OpenTelemetry method. And this then basically defines and configures OpenTelemetry for logs, for metrics, and for traces. And if you want to adjust the defaults here, which are part of the .NET Aspire ecosystem, you can definitely do so and then get started. In our case, we just use the defaults, and then we could look into some aspects in the .NET Aspire developer dashboard. So finally, let's jump to the next challenge. As part of the next challenge, we will start looking into the next folder, which is part of the challenge 2 environment. There you go. So what we'll do now is we'll look into the .NET Aspire orchestration and how we can adjust what is defined in here. So we'll basically export the OpenTelemetry signals to an observability backend, like New Relic, for example, but this is fully based on OpenTelemetry standards. I can use the same configuration for any other observability backend of my choice. So let's jump into the program CS file. In here, I already configured some basics that are important. For example, at New Relic, we have different regions. And so this OTel exporter OTLP endpoint is configured now to use the US region by default. This is a 100% OpenTelemetry native endpoint where you can send in some OTLP data. OTLP stands for OpenTelemetry Line Protocol, and this is then shipped to otlp.nr-data.net. There's a similar endpoint available for the EU region. And then since this is a public endpoint, we of course want to use an API key. And the standard configuration for this is the OTel exporter OTLP headers section. And then we'll send in the API key. And in our case, this is the New Relic license key that we're using. So this is the configuration of the OTel exporter OTLP endpoint and the header section. And then for the different services that we're using, like the API service and the web frontend, we just pass in these parameters, these environment variables, as additional configuration. You can see I use the with environment here, and I'm passing in the endpoint, the header, and some additional configuration. This is also, again, standard OpenTelemetry configuration. I can also define a service name for this service and all the telemetry that is captured, like metrics, traces, and logs for this specific service. And I also have some OTel resource attributes. These are optional. You don't need to define them, but it, of course, makes a lot of sense if you want to differentiate where are the different signals coming from. In this case, I can then tell that the API service and the web frontend have different signals that we receive. So great. So we did this configuration. So you notice there's a New Relic license key that we need to use. How can we get this license key? Well, and again, I have some description in here in the instructions. So the license key, I can get this from my New Relic account. So let's export this New Relic license key as an environment variable in here. And let's jump over to my New Relic account. I can jump into the API keys section, create a new key for me. And important, whenever we want to send data and ingest data into New Relic, we'll use the ingest license key. I could specifically name this Global Azure, create my key, and don't worry, I delete the keys after the recording. I can copy the key and paste them into the terminal here. So the next step is, again, executing our application by triggering the app host project. I can run this. Again, this should be up and running in a couple seconds. In the instructions, again, I highlight, some screenshots and some configuration. Okay, so this is actually up and running. I can go back into my .NET Aspire developer dashboard. This should refresh in a second, and then we can jump into the resources again. You can see, again, I have the web frontend and the API service. I can look at some details again. And this time, since we configured the OTel exporter endpoint and the headers, I can then see here and verify that, yes, my configuration has been accepted for the OTel endpoint and my headers configuration, my protocol, and so on, all the different attributes that I configured here. So this is great. Let's look into some aspects like traces. Let's execute some requests here. Again, this is rejoining my deployment. I can click on the counter again, click on the weather service. You can see this is getting some new weather forecast data. But the developer dashboard in here doesn't show any data in here anymore. And of course, this is expected because we'll send all the data, all the requests now to our New Relic observability backend. And again, this you can use any observability backend that supports OpenTelemetry signals. I can then jump into my New Relic account, click into the All Entities section, and in the section for OpenTelemetry, you can see I have a bunch of different services here. And we can also see I have a service or an entity for the web frontend and for the API service. So great. Let's click into this and into the distributed tracing section. So I can click on the distributed tracing section. We can see some traces that are being captured. The scatter chart shows me the distribution of all the different traces, and then the table down below shows me some details. I can then sort by entities involved, and then you can see there's one or a couple traces that actually hit the get weather endpoint. If I click into this specific trace, you can then see a map like this that we create for the web frontend, making a call, a request to the API service. We can see that this specific trace took 563 seconds or milliseconds. And then the breakdown down below shows me a similar view that we have seen in the .NET Aspire developer dashboard. Again, I can click into any of these spans and look at some details around what it is. We captured some specifics about the request, like the request method, the status code, and so on and so forth, the endpoint on the /weather forecast on the API service, and so on and so forth. Similarly, I can also click into the logs directly from here. So we have these logs in context with the trace. These are all the traces for this specific trace ID. OpenTelemetry basically automatically ingests some additional attributes into the logs. And in this case, I can see there's a trace ID that is being added to the logs. And this way we can then correlate the traces and the logs with each other. What about the other telemetry like metrics? And of course, I can also look into the metrics for all the different services, specifically this one for the web front end. And again, I can look at some default metrics like the .NET garbage collection, for example. We have the similar metrics like CPU time, active requests, and so on and so forth. So this is all similar to what we have seen in the .NET Aspire developer dashboard. So great. What we have seen so far is we spun up the .NET Aspire application. We looked at the telemetry in the .NET Aspire developer dashboard. We exported the data into an observability backend like New Relic, and all of the details again are here in the instructions for the second challenge. So finally, let's jump into the next challenge. So in the third challenge, again, we'll stop the application using Control-C, and then we switch into a different directory here, challenge 3/Aspire. You'll notice that the third challenge has an additional service here. So we have the Aspire application. I moved it into an Aspire folder. So we have the same API service, the web front end, the service defaults, and the API host. And we now also see a GenAI API service as part of the .NET Aspire application. This GenAI API service will actually then make a call to the GenAI application. This is a separate application outside of my .NET Aspire application context, and we'll spin up this application. This is a Python application separately, and the request from the .NET Aspire application will then be made to the Python application. So let's go ahead. For this, we'll need also a second terminal here. And again, we can open up another terminal easily with clicking on the plus sign here. In the second terminal, we actually switch into the challenge 3 GenAI folder. I have some descriptions in here, but we'll actually look into the details in a second. So again, also for the second terminal, I need to use my New Relic license key. This should still be part of my configuration. So if I scroll up here, I'll find the New Relic license key. We'll use that also for the second terminal, export New Relic license key. Perfect. Then for the .NET Aspire application, we can again run this using the app host orchestration. And the Python application, this is our generative AI application. We also need to use some additional configuration. So in this case, let's have a look at the application. This uses a OpenAI Azure inference model. You can see I'm using the OpenAI SDKs here. And for this, we need to use our GitHub token. So we use the GitHub models in here, and we also need to define the actual model that we're using. So in order to get the GitHub token, I already exported this and will use this as part of the sample here. So I'm exporting my GitHub token into the second terminal here. Paste this in, I copy in my GitHub token. Again, I will delete this after the recording. And then as part of the application, we use a GPT-4o mini model, and this is what we define here in the model environment variable. Next, we'll just execute the application. You'll notice that this is a Flask application that we can use. Let's get this up and running. First of all, we create a virtual environment, get all the dependencies using pip install, and then we'll actually spin up the application using Flask on the app.py. So this is up and running on port 5004 already. I can make sure that this is also forwarded. Nice. But this is now also part of my .NET Aspire application. You'll notice this in a second. Once this is rejoining the server, you'll notice I have again my home, my counter button. I have the weather forecast that we can see. And now there's also a Gen AI section in here. So I can then ask any questions like, who are you? In here, I can get the response. I'm a large AI language model created by OpenAI. What do you know about, oops, if I can type, about New Relic? Let's get the response and see what it thinks about OpenAI, thinks about New Relic. Here you go. There's a response, focusing in, of course, on APM, because this is kind of like a category that we invented. Great. So now that we captured some requests, again, the README goes into some details and also explains what is happening. Let's have a look into the telemetry that we captured for this application. So we are now actually using a New Relic agent that is observing the Gen AI aspect. And I'm using this because we already added some capabilities to capture AI monitoring telemetry from this application. So this is a part that is not yet fully running on OpenTelemetry. I'll get into some aspects on OpenTelemetry in a second, but let's jump back into the web front-end service and into the distributed tracing section. And if I then sort by entities, I should see at least a single trace that has some additional entities involved and a lot of different spans. So if I click into this one here, this is actually one of the traces that we captured that interacted with our Gen AI service. So you can see from the web front end, we're calling into the Gen AI service, which is part of my .NET Aspire application. This then makes a call to the Gen AI backend, the Python application that we captured. And this then makes a call to the model interference API. This is, of course, an external service that we are calling. At the bottom of this, we can then also look at the timeline of how was and where was the time spent. So you can see in total, this took like 1.2 seconds. And where is the time spent? And of course, the majority of the time is, as we would expect, on the post request that we'll send into the models inference ai.azure.com API. Great. So if I then go into some of the details here, for example, on the Gen AI backend, I can then look at some additional configuration that we captured, some entity name, and so on and so forth. Is it using LLMs? Yes, this is set to true. Interesting. And now we can jump deeper into this specific service, for example. So if I click into this Gen AI backend link, you'll notice this is showing up the summary view. I can look into the traces section and so on and so forth. But one thing that I wanted to highlight is this section here on AI monitoring. This is something where we captured some specific information about the AI aspects. And if I jump into the AI responses section, I can then look at all the interactions that this Gen AI backend did with any of the AI, LLM, large language model services that are out there. This could be requests to OpenAI, Gemini, AWS Bedrock, Azure, OpenAI services, and so on and so forth. We capture the total responses in the given time window. So in the last 30 minutes, we've seen 2 requests to a AI backend, the response time for this, the token usage, is of course also important, that because this directly influences the cost that we have to pay and some errors that we may have seen. In this case, we haven't seen any errors. So I can now look at the similar information over time, and also I can look into the actual requests, the prompts, and the responses from my AI. So if I click into any of these traces, this will open up a trace view like this, where I can see this specific request took 5.8 seconds, 439 tokens have been consumed. I can also look at the response details like the user input, what do you know about New Relic, and the response from the AI, including some additional meta information like the model that we used, the ingest source, the finish reason, and so on and so forth. And we also highlight the specific AI spans from this trace in here. Of course, this is the default. If I want to, I can also enable some other information like all the Python middleware and so on. But this is not the focus for this here. And then we can look at also the details for some of the spans that are directly related to the AI interaction. Some other sections that we added are also like model inventory. And this here, I can then see which of the models do we use, how many requests did we see, what was the average response time for this specific model, and the average tokens per completion. There's some other aspects on the errors, the performance aspects like the token usage and so on and so forth, and the performance as well. So great. So we captured some information here, but we only have information for one of the models. So imagine we running some kind of evaluation on what is the best model to use for the use case that we are putting out there. So maybe the most important aspect for us is the performance. I want to use a model that is responding as fast as possible. Then maybe I'm having a focus on the average response time. Maybe the cost is important, and maybe the least amount of tokens being consumed is of interest to me. So these are all aspects that we can observe here, or maybe also the quality of the responses. I can then look at the different responses here and observe what is happening. How is the quality different for different models that we're using? And this is exactly what we'll try to observe now in the next challenge, where we look into using different models and using the same application to observe what is happening. Again, in the instructions here, I highlighted a lot of what we already have gone through. So let's click into the next challenge. This will bring us into challenge 4. So in this fourth part of this talk, I will actually change into the challenge 4 directory here. Let's stop these applications in the terminal. Let's switch into challenge 4 folder. Great. The same then also for the GenAI application. Perfect. So I have some additional information in here on what is the challenge for this. We want to observe different models and see and compare like the different aspects on performance, cost, and quality. So for this, we are now using a different model. We use and switch the model to GPT 4.1 mini. So let's export this environment variable, and then let's get these applications up and running again. So first on the .NET Aspire application, and secondly on the GenAI Python app as well. I have also some instructions here, like how to interact with the AI application. If you want, you can use any of these sample prompts. Let's see, for example, this one here, who invented New Relic. Let's jump back into our .NET Aspire application. Again, it's the same application that we're looking at. I can look into the GenAI section and paste in the prompt. Let's see what it thinks. Yes, New Relic was founded by Lou Cerny. Let's use some other information, like why should developers attend Microsoft Build Conference? Also a great conference here. And again, here's some aspects on this. So great. So now we used a different model, but that's not it. Let's jump and add some other model. So let's switch the model into GPT 4.1 Nano. For this, we'll stop the Python application. I want to export the model here. We're using GPT 4.1 Nano, and let's start up the application one more time. Once the application is running, again, you can use some prompts. Where does the name New Relic come from? Let's try this one. And I'll execute this. Let's see what it thinks. The name New Relic was chosen to reflect the company's mission, and so on and so forth. Great. Just for the sake of it, let's use one more prompt here so that we have some data to look at. Tell me more about .NET Aspire. Here you go. Certainly, October 23. That was exactly right. So, okay, let's go back into our GenAI backend application. Let's look at the AI responses section. And you can see we added in total, we have used like 6 different requests to our AI. We can look at the response time. We can also add the average, the P95 or the P99. You can see there's a huge difference here. The token usage per completion, we didn't see any errors. Now we can see also the breakdown here in the section, and we can see the exact same requests, the prompts that we submitted, including the responses. If I scroll to the right, you can see the number of completions per request. You can see the total tokens being consumed for the different models that we used. We had like 2 different requests for each of the models. We started with GPT 4.0 mini. We then switched to 4.1 mini and finally 4.1 nano. You can basically use any of the models that you have access to play around with it and see what was the performance of my application. If we then jump back into the model inventory section, you can then see the breakdown on all the different models here. I can see how many requests did we notice for each of these applications. I can then sort by average response time, and you can see there's quite some differences in the average response time for these. GPT 4.1 mini seems to be like the fastest in responding. GPT 4.1 nano seems to be the slowest. But of course, this could be because of the different prompts we used. I highly encourage always, if you do some evaluations like these, to use the exact same prompts so that also the models have a similar perspective. I can then also, of course, sort by the number of tokens per completion. In this case, 4.0 mini seems to be the lowest number of tokens consumed, 4.1 nano the highest, the error rate, and so on and so forth. I can then also look at same information over time. Did we see any patterns here? When was specific models been used in my entire interaction? And of course, I can also look again at the different completions here. Again, I can focus on the performance aspects for the different models that we're using, which of those responses in the fastest manner, and also the cost, where we can then highlight the actual tokens consumed by the different models. Again, highly encourage you to play around with different models, look at which of those is the best model to use for your specific use case. And let's evaluate what is it that we want to use. Finally, let's jump into the next challenge. So in challenge 5, what we'll actually do is we try to look at some of the data in more detail. And what does that specifically mean? So you have noticed that we always talk about tokens. As a matter of fact, there's even some breakdown into input and output tokens. So whatever prompt you're using, the prompt will be broken down into different tokens, and also the response from your AI. Of course, all of these different models and the different vendors have different price points. And what I did is I basically created this so-called CSV table that basically contains some pricing information for the different vendors and for the different models. So in this case, you can see I'm defining the response model, the cost for the input, then the threshold for this. So let's actually look into some actual pricing here for OpenAI, for example. You'll notice that typically all these different models have different price point per input and for output per 1 million tokens by default. And this is exactly what I entered in here. So we have a price point of 0.5 for GPT 3.5 Turbo per 1 million input tokens, $1.50 for 1 million output tokens, and so on and so forth. So what we can do is we can import this CSV file into New Relic. I have the instructions in here. I already did this, and I have, if I jump into the log section, a lookup table created called AI model cost. And you can see there's 18 rows in here with data. And then also what we can do is we can add some custom dashboards. And I also created this example dashboard in here, which basically shows some information for the different requests that I entered in here. You can, and this is what you have to add is your New Relic account ID before you import it. And you can see this refers to the lookup table that I entered AI model cost and does some calculations. So basically, I already imported this model. And if I jump into the dashboard section in the AI model comparison dashboard, you'll notice this is the content of the lookup table where you can see all the price points for input and output tokens. And then what I did is I basically calculated out of the token information that we received from the interaction with our AI model, I basically able to calculate the actual cost in dollars for each of the models and the tokens being consumed. And you can see there's some huge differences in the price point. So for the few requests that we have sent in, GPT 4.1 mini seems to be the highest cost. But again, this could be based on the number of prompts that we use, the different types of prompts. And GPT 4.1 Nano seems to be the lowest price point when it comes to actual cost in dollars. So there are some really nice things that you can do when looking at all of the data from your AI applications. Going back into the instructions here, this should all be described here as well. I can look at some details for all the costing aspects in here based on actual dollar amounts and not only tokens. So next, let's jump into the last and final challenge for this. So in this last challenge for this talk, I focus on some aspects on how you can use OpenTelemetry to capture similar information from your AI interactions. Again, I used a New Relic APM agent before to capture some data. And the reason is because OpenTelemetry has not yet standardized on the AI monitoring, the LLM monitoring aspects. There's a lot of different projects out there that do similar things, but there's not like a single standard yet and an agreement on how should AI monitoring be incorporated into OpenTelemetry yet. So there's a project called OpenLit, and I have a link to the project in here that actually covers some aspects on AI monitoring, evaluations, and so on for OpenTelemetry-based libraries designed to streamline the monitoring aspect. There's another project called OpenTelemetry that is doing similar things. They all focus on slightly different aspects. Some have more and some fewer capabilities when it comes to capturing the tokens, the content also from your prompts and the responses. So some capture this detail, some don't. There's also a lot of different support for different vector databases and embeddings into your configuration. So OpenTelemetry has some support for this, but there's a lot of other projects out there that focus on similar aspects. There's one from Arise Phoenix, LangFuse, Langsmith, Langtrace. All of them cover a similar aspect when it comes to generative AI with OpenTelemetry. So I encourage you to stay informed. Hopefully, this is also been formed into an open standard on how to capture telemetry from your generative AI applications with OpenTelemetry. I'm really looking forward to that. And this is then really finally what will be a game changer in the industry. Open standards is really the way to go forward. And this already brings me to the end of this talk. I have a couple links here and some information on OpenTelemetry for generative AI. There's a nice blog post out there. I put in the QR code and the link to this specific blog post. There's also a section in the GitHub repository for OpenTelemetry that talks about the generative AI aspects from an observability perspective with OpenTelemetry. Again, there's a QR code and the link here. Call to action. I hope this was inspiring. I hope have seen how we can use .NET Aspire to use and implement these applications. This is really a really nice environment to make sure that you build scalable and robust applications across your complex environment. So I encourage you to look into .NET Aspire if you haven't looked into it yet. OpenTelemetry is something, of course, here to stay. A lot of companies from different vendors are contributing to this standard. We at New Relic as well are highly invested in this and contribute to OpenTelemetry. And then from a generative AI observability perspective, we at New Relic have some ways on how to monitor your AI interactions. We've looked into some details when it comes to evaluations and some model inventory perspective. But there's also OpenTelemetry that is going into the direction of observing AI applications in this context. So with that, thank you very much for listening to me. If you want to learn more, you can reach out to me. You'll probably find me on various social media, LinkedIn, GitHub, whatever is your preferred way of contacting. Thank you so much, and I wish you a great rest of Global Azure Conference.